be tough. It's not only my content that I have in here, so we're a team. It's called Team RGE, and these are the three guys that are responsible for that, actually. No, in reality it's Ruben and Sean and I who put all the content together, and Ruben had the idea to create this Team RGE, Team Remote Graphics Experts. It's really funny. We even have our own logo now. We all used to be CTPs, MVPs, and vExpert, except for Sean. He was kicked out of all of the programs after joining VMware. For obvious reasons, he cannot be a VMware or vExpert when he is working for VMware. But also Microsoft and Citrix immediately kicked him out of the program after he joined VMware. So that was the thing. Good. What is the goal of our session? So I'm going to talk about this, GPU accelerated graphics remoting, which is sort of an add-on to what we heard from Jack. And so looking at the GPU stuff from an independent standpoint. So how do we test? What is GPU acceleration exactly? We're talking about bandwidth versus latency, so it's about the network. So some hard lessons learned, and what's next? So this is what we do. So when talking about hardware accelerated remoting, we're talking about a GPU on the host side and little Benny sitting in front of a PC or any device and wants to connect to this backend, and this is exactly what happens. As you see, we can have CAD/CAM applications running on a thin client or whatever you're sitting in front of. Now, how do we measure remote end user experience, re-UX? User experience is something different because that's about the user interface elements and the design. Now, we're not talking about user interface design, we're talking about performance of the user interface. And in particular, we're talking about the impact of host and client hardware. So the GPU acceleration, what kind of impact does it have on the overall performance? So you see, there's a lot behind that, and measuring that is not trivial. So it's like an art, it's like science, and it makes it interesting. And there is no standard methodology out there so far. So this is why Sean, Ruben, and I had to come up with our own methodology, how we measure that. So the problem here is that frame rates, and in particular NVIDIA likes to refer to frame rates, is not the adequate way of measuring it. Jack pointed it out. The remoting protocol typically delivers a fixed number of frames per second, no matter what happens. So sometimes at 30 frames per second, sometimes at 60 frames per second, no matter what's going on. And so measuring frames per second doesn't make any sense if we were talking about remoting. It makes a lot of sense for local experience. Performance counters, well, the funny thing is, if you're looking at performance counters, sometimes your system looks very good, but users tell you it sucks. So it's really hard to find out from performance counters alone why the system performance is not what people expect it to be. So we have additional criteria when we are looking at remoting. So the perceived user experience, so you have to do a visual analysis, and you have to look at the specific remoting performance counters. So what are the client capabilities, what can they do, what kind of graphics formats are supported. So is the user interface performance degraded by some of the things? Is there a delay in response time? Are there compression artifacts? And so on and so forth. And also the media synchronity. So if audio and video is in sync, what we refer to as lip syncing. So when you see a speaker, you want to hear the sound at the same time it comes out of his mouth. And if you are watching a movie where that is not lip synced, it feels odd. And so users cannot deal very well with such a situation, so we have to look at that. So when you want to do testing, so you need a client, you need a network, you need a host with a guest system installed there, you remote into the guest, and you use a tracking PC to see what's going on. You observe the client, you control the host, and you archive your results. That looks simple. In reality, it is a little bit more. So when you look at that, it is complicated to set up such a lab. And it took us a couple of years to find the right components for this lab, and we made sure that it's reproducible. So not only I have this lab at home, Sean has the same lab at home, and Ruben has the same lab at home, allowing us to reproduce each other's results. Only if a result can be reproduced, it's a valid result. This is what I learned when I worked in research. And so we have frame grabbers to record videos, we have those, and we had this conversation earlier today with those WAN emulators. So we're using hardware appliances to do WAN emulation. So any WAN conditions we can simulate. So this is the idea of this box here. And after we recorded videos with a frame grabber, we do some post-processing. So sometimes it's hard to play back those videos because it's huge video files that we're recording. And so we convert them into a format that is easier to digest from the machine that we want to play it back on. And then we have something, a custom developed video player that allows us to run 4 videos simultaneously. You will see that later, how that looks like, which allows us to compare stuff that we observe on the clients visually. So that gives us the opportunity to look at something and say, hey, this is better than this, without having performance counters or any other weird numbers that tell us what is better and what is not. It's also compatible to managers, because managers don't understand if we tell them some scientific facts. What they understand is, hey, this video looks better than the other. This is very simple. Even CEOs get that. So, like I said, we're using this video player, so 4 videos side by side, and sometimes we do it differently, so we only have 2 videos, we call them 2x2s, so we have 2 videos, we compare those 2, but also have some telemetry data that is related to one of the videos. So here we have the network bandwidth that is required by this particular video, and here's a network bandwidth required by this particular video, but later you will see that in real time. So, let's move on. Let's go on to the GPU acceleration. How does that work? First of all, we heard about NVIDIA. Yes, NVIDIA Grid is by far the most popular acceleration technology, but there are still many people out there who say, no, we have no specific video encoding hardware in place. And most of 15% are not even sure what we're talking about. And so there's a lot of market that is still not covered, which is interesting. You see, there are the others like Teradicci Offload, NVIDIA Quadro, and here AMD Fire Pro at 0.5%. So it's very clear that NVIDIA is the market leader as far. Well, if people know what they want to do with the GPU acceleration, typically they are using NVIDIA. Now the question that we heard earlier is it any significant market? And you have these designers, everybody's talking about the CAD/CAM designers, but they are power users, knowledge workers, and task workers. So you see, most people are still task workers, but we still already have many knowledge workers. The question is how many are out there? And for what kind of users, what kind of GPU or hardware acceleration is needed? So for the task workers, we can use software rendered graphics, so we don't need any GPU. But starting with knowledge workers, it's good to have GPUs and use GPUs in a shared way. So you've seen what Jack presented, that there is this shared notion of using GPUs, so it's not one GPU per user. It's only reserved for designers. These designers want to have dedicated GPUs, independently if they want to have them locally or on a remote machine. But how many users are out there who could benefit from a GPU? And the numbers are from NVIDIA. They asked market analysts to find out what the market numbers are. 20 million designers. That is a niche market, because today we are talking about 1 billion to 1.5 billion enterprise desktops out there. So out of this 1 billion, we have 25 million that are designers. not a significant number. This is the high-end NVIDIA addresses. Now, but look at the power users and knowledge workers, 200 million, 400 million. So roughly we are talking about 500 million users that can benefit from GPU acceleration. The question is, what kind of use cases are out there? These are the real high-end use cases. Construction, engineering, oil, gas, and so on and so forth. As you can imagine, in Germany, automotive is very important. If you go to Norway, they will do oil and gas, so this is what is important for them. So different geos, different profiles regarding those requirements. But look at that. These are other applications that can benefit from GPU acceleration. So there are the CAD/CAM apps in there, but there's also Firefox. There's also Internet Explorer. There's Office. Because they all are based on DirectX. In particular, the browsers can benefit massively from GPU acceleration. And like Jack pointed out, every mobile phone has GPU acceleration built in. Now you're watching YouTube on your mobile phone. Why does that work? Because you have a built-in codec chip that does the decoder, that acts as a decoder for the YouTube videos. Without that, you wouldn't be able to watch YouTube videos on your mobile phone. Now here we want the same in our remoting infrastructure. We want to be able to see YouTube videos or whatever multimedia content is out there. And the same is true for any interactive graphics in a browser. Same thing, Flash, WPF, you name it. We want to be able to accelerate that. So we have this spectrum, and Jack already showed us this spectrum. So we have software graphics, we have the shared GPU, GPU pass-through, GPU virtualization. I'm going to walk you through those and show you some examples, what that all means. But we also have the direct map, which means this is the bare metal. Let me show you how bare metal works. So you have your hardware and your operating system. So you see you have CPU and memory. CPU and memory do not require any drivers. So the OS runs directly with those devices. While for hard disk, NIC, and graphics card, you need drivers. The hard disk drivers are built in the operating system, so that's not a big deal. But the network cards and the graphics cards, they have vendor-specific drivers. So if you have this operating system, on top of that, there are the interactive user sessions, or in the case of the Windows workstations, it's one interactive session and the session 0 that hosts all the services. Now you're able to remote into the interactive session using one of the standard remoting protocols from a remote client. So this is the idea. Interesting enough, Microsoft does not support any GPU acceleration when you have workstation to workstation communication. So physical machine to physical machine, there is no hardware acceleration on the Microsoft side. VMware and Citrix, they have those scenarios. So if you have extra hardware in your client, I mean, in the client you remote into, then you can use that hardware to accelerate the remoting protocol. Now software graphics, we put the OS on top of a hypervisor. And we don't have any GPU in the hypervisor, so the CPU, what it does is it emulates the GPU. It pretends that it's a GPU. The reason is very simple. The application believes that there is a GPU, and there's no change in the software required, so it works as if there was a GPU. But the CPU is not a GPU, and it can never be as performant as a real GPU. Because the thing is, we're talking about multi-core CPUs today, like 2 cores or 8 cores, and we think, wow, this is huge, 8 cores in one CPU. If you look at a GPU, there are thousands of cores. Like A typical grid card, with a K2 grid card, we're talking about 3,000 cores in 2 physical GPUs. So this is a major difference, because graphics is, you can act on graphics in parallel. So it's parallel computing, massive parallel computing. And this is why the graphics can take advantage of those many cores. While a multi-purpose CPU with only 8 cores, it can never simulate a GPU with 1,500 cores. And this is why this will never be as performant as a real GPU. Now if you add a real GPU, we have this shared GPU thing, this API intercept, where Jack said, this is not so good because it is hard to support all graphics formats. This is correct, because what you do is you have this virtual driver in here, the synthetic driver that comes with the hypervisor, and what it does is, he called it a shim driver, and a shim driver is like a filter driver. So what it does is, whenever there is a graphics API call, this virtual driver grabs it and forwards it to the real GPU. Now, if one of the graphics formats is not supported here, it's just ignored, and it throws an error message, like an OpenGL error message. No, OpenGL is not supported. And this is what happens in many cases if you're using this technology. But Microsoft, they have the ambition to implement every single graphics format that is in the market today in their generic drivers. So this is why Microsoft will continue to do this, because it's independent of the vendor of the graphics card. So it's not an NVIDIA technology. It can also be used by hardware provided by AMD and Intel. This is important for Microsoft. Cenab, if you do Cenab GPU sharing, they introduced the native driver provided by the GPU vendor and allows to talk directly to the graphics card. So it has the full fidelity of all graphics formats that are supported by the native GPU driver. But that's a very specific way Citrix deals with that. GPU pass-through, Jack mentioned that. So what you do there, you punch holes in the hypervisor and allow the native driver of the graphics card in the VM to talk to the hardware. Basically what you do is you allow the graphics driver in the VM talk to the memory space that is reserved for the PCI device, which is the GPU. So you open that memory space. Microsoft clearly says they will not support this technology only over their dead bodies. That's what they said. Because by punching holes in the hypervisor, you lose control. Which means if the driver does stupid things in the memory, it blue screens or purple screens on the VMware side the hypervisor, and this is what happens. So you have to be very careful. You lose control, you lose stability, and for Microsoft, stability is the most important thing. So they will not do this technology. Citrix and VMware, they're supporting pass-through GPU. And now you have this NVIDIA Grid vGPU. Be very careful, Microsoft calls their shared GPU technology also vGPU, so that is RemoteFX vGPU. In this case, it's NVIDIA Grid vGPU. So here is the broker component. You remember when we were talking about can we use the same drivers here for the NVIDIA vGPU and for pass-through? No, we cannot, because the NVIDIA vGPU driver relies on knowing that there is a broker component that lives in the hypervisor that assigns the resources to each individual VM. So this is the fundamental difference between those technologies. Now you look at that, Microsoft only has soft GPU and has this GPU sharing API intercept, this shim driver. While Citrix and VMware, they have the entire spectrum. They offer everything. For NVIDIA, this is great, because they were able to convince two of the major players to only use their hardware. They are not able to convince Microsoft in the same way. So this is what we're talking about when we talk about GPU accelerated. And this is one of the, Jack also had one of those pictures, the matrix, which graphics forward is supported by which technology. So you see, sometimes OpenGL is a big problem, and sometimes, in particular, CUDA is a big problem because CUDA is NVIDIA only, so it's only for, well, exclusive NVIDIA technology, or if you're using NVIDIA graphics cards, it's available. So you see, this is really hard for people to find out what they really need. Because if you're asking an IT pro, hey, how many OpenGL applications do you have? How many OpenGL 4.0 applications do you have? Typically they don't know, because there are no tools out there.
Lakeside.
Yeah, sure. Lakeside can do that,
yeah,
but it's expensive.
Okay.
So let's take a look at GPU accelerated remoting. What does it look like? So, as I said, we recorded some of the videos, and those videos allow you just to visually compare. We have here bare metal on my laptop here. Then we have bare metal on a K5000, so high-end CAD-CAM graphics card. So that's a local experience. You see 7,000 frames per second. And now we're doing that in Microsoft vGPU. That is not so fast. And then we have the HDX 3D Pro pass-through. Okay, we're seeing like 1,500 frames per second. But those 1,500 frames per second are not delivered to the endpoint. There's not more than 30 frames per second that come to the endpoint. However, if you just compare what it looks like, hey, it's pretty similar. So we're really getting there. This is really interesting to see. What's even more interesting to see, we had scenarios. Again, we have here the bare metal, my machine, which comes with an NVIDIA card, and the K5000, and here the Microsoft vGPU and Citrix. And when you look at the performance down here compared to the performance up here, you will see as soon as it has loaded that this performance is better than that performance. So for the first time, that was about 2 years ago, at that time for the first time we were able to beat local performance with remote performance. And it will move forward like that. Because now first people started asking, hey, can I add more than one GPU on the back-end side? Because in bursts I may want to use like 4 GPUs to have really fast graphics. I cannot get 4 GPUs in one physical client, but I can have 4 physical GPUs in the server. That works. And so long term we will see that remoting will be faster than local performance. This is really interesting.
Wow.
And I mean, I have many of those demos here, as you can see. So these are all LAN-based scenarios, and they allow me to do that kind of comparison, like soft GPU versus the remote FX vGPU versus remote FX vGPU on Windows 8 versus remote FX vGPU on Windows 10. So you see how it step by step improves the quality. We will talk about that a little later when we're talking about the new things that come with Server 2016. And but you can also see I have one example where it kind of crashes. I think this is the one. You see here, that's a typical error message that you get when OpenGL is not supported. This is also user experience. The user is not happy about that. Because while all the others, they do their job, they start doing this rendering in OpenGL, the other user here with the old remote FX only sees the error message because OpenGL is not supported by Microsoft in this early version of remote FX. Good. So let's go back to the slide deck. Now let's take a look at bandwidth versus latency. Like I said, now we're talking about the network. Because bandwidth, everybody always thought remoting is all about bandwidth. No, it's not. Because the latency has a significant impact on user experience. Also packet loss. If you lose packets on the way from, for example, from a cloud data center to your client. And the thing is, what is stronger? And what we found out is that if you provide between 2 and 8 megabit per second per user session, then latency becomes the limiting factor. So adding more bandwidth does not help. And in order to measure that, we came up with certain standard scenarios regarding bandwidth, latency, and packet loss. Like in LAN, same continent and medium performance, same continent fast, like 8 megabit per second, 50 millisecond latency. That's typically what you get within a continent. If you go cross-continent, it's more like the 200 milliseconds. Packet loss, this is more a scenario, cloud scenario, while almost no packet loss, this is when you have these lines. And again, let's take a quick look into some of the videos, what the effects are. For example, here, what we do is we have LAN, and we have, hey, that is also LAN. That is not the one that I wanted to show. Here we are adding 8 megabit per second, 50 milliseconds remote FX. So you see, remote FX pretends that it renders 500 frames per second, but you see, those 500 frames per second don't make it. And even though Citrix, with their vGPU implementation, they only tell us they have 60 frames per second, but obviously those 60 frames per second make it to the client. So performance is much better here than it is there. And the bandwidth that is required to generate that is higher than the bandwidth to generate this one here. And it gets even more significant if we're adding more latency. Now we're talking about 200 milliseconds latency. So we still have 8 megabit available, but Remote FX is only able to use about 1 megabit. Because of the latency, it cannot use more bandwidth. So adding bandwidth would not help. While on the other side here, you see Citrix is able to deal a lot better with the latency. So they also cannot use the full 8 megabit, they only use 2.5 megabit, but it's a smooth experience. So this is what you introduce, the kind of user experience you get when you're introducing latency and packet loss.
And this is all UDP, isn't it?
It's TCP.
Right.
In this case, it's all TCP.
Benny, forgive me, have you published this in a white paper? Has this been made available publicly to review?
No, I'm working on creating the videos and the blog articles now.
Okay.
So only during the conference presentations.
Okay.
So there are recordings out there, like on Channel 9, the Microsoft recordings, there are some of these examples are out there.
Yeah, I think your conversation around latency and bandwidth would be very helpful to get the customer better positioned for it. So, are any of your videos PC over IP? I'm seeing lots of HDX.
Yes, absolutely, absolutely. We can look at those later. So we have the entire things. So it's not only the Citrix protocols, it's also the Teradici protocols and everything. Ooh. Start from the beginning, please.
Alex, will you be emailing the presentation to see if people take pictures? Okay.
I understand. Thank you.
Hey guys.
So what are
the presentations are all going to be available.
Yeah, we got to give you the presentations.
Okay.
So things that we learned. First of all, Jack already mentioned it. We need compatible servers. Either you build your own servers and make sure that all components that you use are compatible. I have an article in my blog that describes a white label server that we built if you want to go cheap. Like we're talking about like €2,000 or $2,000 to build one of those servers. So it's relatively cheap compared to those machines. Here we are talking about $10,000 to $15,000 per machine. So if you want to build your own lab, go for the white label machines, but you have to make sure that the BIOS requirements are fulfilled in order to do vGPU, the grid vGPU. So if not, those VMs will crash. And sometimes it's hard to find those places in the BIOS, like, hey, Xeon Phi support enabled, that did the magic trick for that particular, that is an ASUS BIOS. And here's another one, you see above 4G decoding is enabled and Intel Xeon Phi support again is enabled. So these settings make the magic trick. If this setting is not available in the BIOS, it's not going to work. Make sure you buy either the compatible servers or these requirements are fulfilled. Then you can do all that stuff. You can configure, here these are the screenshots from the Citrix configuration. Then you can configure those grid profiles that Jack described in his session. So this is the picture of the Citrix console. What Jack had in his slide deck telling you that one profile can only assign, well, one particular profile can only be assigned to one GPU. So you cannot mix the profiles within one GPU. So this is also represented here. So you have this profile that where you can have 4 VMs per GPU, and here you have another profile that allows you to have 2 VMs per GPU. You cannot mix those.
Is there a way to create your own profile?
No. No. These are predefined. Yeah. The other thing, and he mentioned that already, power supply. Because the grid cards and also the AMD cards, they are power hungry. So you have to make sure that your power supplies support that. The white label servers we built have 1,000 watt power supplies. The Dell servers, they have the 1100 watt power supplies. If you buy another one, the machine will not boot. As soon as you plug in the grid card, they will simply not boot. The white label servers, they will boot, but they will not work properly. Final thing, what's next? So, my impression is that VMware vSphere, they started replacing Citrix Xen Server as a dominant grid platform. So Xen Server was only relevant for those customers that wanted to use NVIDIA Grid vGPU. But now, obviously, even Citrix understands that now they want to run their Xen desktop on top of vSphere. That is Grid vGPU enabled, which is funny. The GPUs that are built for server platforms will get new ones. Like I mentioned before, K3, K4, they are in the pipeline. So unfortunately, Jack did not mention it. I don't know if it was.
He didn't want to.
No, he said that this year.
Yeah. Okay.
But you know.
Intel is entering the game because with their Iris Pro, so they're putting high-end Iris Pro graphics capabilities in their CPUs, in the Xeon CPUs, and this will be very interesting. So because they want to come from the low-end market and go up, while NVIDIA comes from the high-end market and goes down, and then try to squeeze out AMD.
Yeah.
They want to make it a 2-vendor market.
They will.
And the prices for GPUs are dropping dramatically over time, like they are in the gaming market as well. So if you take the last generation GPU, it's massively cheaper than the latest GPU. This is going to happen on the server side as well. And GPU is becoming a commodity. As I said, 500 million users. That's not a niche market anymore. I truly believe in 5 years from now we will not have this conversation anymore because every remoting infrastructure is GPU accelerated. Like every laptop, every mobile phone is GPU accelerated today. And the same is going to happen for remoting.
Is there like an AMD kind of thing that you
There
recommend
was.
into
They
it?
introduced stuff that they wanted to do, and I had long conversations with AMD, and they sent me all the cards. I have the S7000 and the S9000 at home, but it never came to life. I have no idea what happened to the technology. I think that AMD has other problems they need to solve first. And the thing is, it's more and more about the application, not the desktop. And very clearly, the ultimate goal is to beat local performance. Like I said earlier, if we're able to have more GPU power assigned to one user if he is using remoting technology, that is very attractive. And this will be something that will be used in the future.
Actually, not only for a service provider, also for a game.
Everything.
Game hardware.
Yeah, because this is why I answered this question earlier,
Gaming.
that gaming industry is actually looking at this technology, and they want to use it. For
And then
obvious
they can
reasons.
sell service to the customers.
The only thing is latency. So if the data center is too far away, if we go beyond 50 milliseconds, performance degrades massively. You've seen the results. If I have 200 milliseconds, there's nothing you can do. It's the physics.
Azure.
It's interesting because the regional data centers are suffering from the
Yes.
big global data
It's just
centers, so
have to
there's
do it
actually a
on
reason to
Azure.
put a little bit of local hardware back
Yes,
into.
yes, absolutely. So local hardware will come back, and this is why all, like the Azures and AWS in this world are trying to build as many data centers as possible.
So, I'm in Los Angeles, and lots of film, video. I met a gentleman who's the architect at Autodesk, and I was talking to him about this, and his response back to me was, when I've got a video artist making a movie,
Yep.
they're looking at the screen, the digital screen that they're making, and they want every element of the pixel that they can get on that screen,
Yes.
because that is the art that they are making,
Yes.
right? So in that context, I'm watching the videos, you're talking about the CPU cores of the grid card and the rest. Are they really losing it by, if they're within that 50 millisecond, is that artistic goal of having
They're
every
not
element?
losing the pixels. What they lose is the interactivity. So there's a lag.
Okay,
And that is the problem. If they are really designing stuff interactively,
Right.
then it may not be such a good
Right.
user experience.
Okay.
However, if you're able to accelerate rendering,
Yep.
that is the other thing.
Yep.
Because how
Rendering is
long will he need to wait after he did the design phase and now do the fine-tuned rendering? And if that goes down from like 2 hours to 10 seconds,
so I would see that as a staged work process,
Yes.
and a core team
Yes.
doing it physical and then release it.
and this is why I believe that these core CAD/CAM designers, they will always have their local machines. These 25 million people,
Yep.
they want to have their local machines, and sometimes even with multi-GPUs in the local machines. These are very expensive machines. We have customers in the automotive industry. I mean, these PCs are 30 to 40,000 euro
Right.
machines.
Mhm.
And but this is only for this niche
The first
market.
one. So-
But those other people that contribute, like
Right.
the contractors, and,
They're not making decisions about the color.
Correct,
Right.
correct. They just do the job. And
Right.
those are the 200 million. And they will be able to benefit from remote graphics.
Okay, we'll chat over beer.